And in this video we are going to discuss about the straight lines. So straight lines, everyone knows this is a line which is just a straight. That does not make any sense. Straight line is a straight line. Okay, what does it mean? Straight line. Straight line. This is a straight line. So to understand the straight line, we need the reference point and the coordinate axis. So I use, this is my coordinate axis. It goes like this. So okay, let me remove this and make it one little better. Okay, so this is my coordinate axis. This is OY, this is OX, and this is a straight line. The general form of a straight line is AX plus BY plus C equal to 0. This is your straight line. It represents AX plus BY plus C equal to 0. A is a coefficient of X, B is coefficient of Y, and C is a constant term. This represents a straight line. Now suppose if A is 0, then you get by plus c equal to 0, and if you plot you will get y equal to minus c over b. Means y is becoming negative. It means this is my y-axis and y is becoming negative, so it will something like this. So this is y equal to minus c over b, and this point definitely will be 0 comma minus c by b, and this distance from here to here is minus c upon b. So distance for distance minus does not make any sense, so this is c upon b. Now if case number 2, if a is not equal to 0 but b is equal to 0, then you get ax plus c equal to 0. So x equal to minus c by b. Now x is negative, it means it will go somewhere like this. This is x equal to minus c by b. So this is a straight line. Now if you have a line, the general equation of a line in the form of slope. Slope means the line, the inclination, this one, this is called the slope. Means this is m, the tan of the angle made by the line with positive direction of x-axis is called as the slope of the line. So to just explain you the basic fundamentals, from here I am returning back to the coordinate system just in a while. So to explain the basic idea, again I am returning back to the coordinate system. So this is my y-axis and this is my x-axis. This is y, this is origin, this is x. So suppose this is a point A with the coordinate x1, y1, and this is with the coordinate B, x2, y2. If you join them, then you can find the distance using the formula AB equal to under root x2 minus x1 whole square plus y2 minus y1 whole square. Okay. Now at the same time, suppose if you do not understand how I got this result, so I simply suggest that I just let me complete. This is my x1, this is y1. From here, this is x2 and this is y2. Now join these two lines. So this line I call it as M. So this is, now you see this is y1 and this is y2. So this part will become y2 minus y1, this part. So y2 minus ym, this is bm, this is b, this is m. So bm is y2 minus y1, and this distance is x1, and this distance from here to here is x2. This is x2, this is x1. So what is this distance? x2 minus x1. x2 minus x1. Now you see this is a right angle triangle because this line is parallel to this line and this line is parallel to this line. So the intersection of these two will be just like this. This is 90, this will also be 90. So if you use Pythagoras theorem, then here you can find AB square. So AB square is this square, first I write this square, AM square, that is x2 minus x1 whole square, x2 minus x1 whole square plus y2 minus y1 whole square. So AB becomes this. This is how I got the result. Now in terms of the slope, because I told you that this line is parallel to this line, so what the line makes angle with the positive direction of x-axis, that is this direction. This is positive direction of x-axis. So if I want to understand that what this line is making angle with this direction, so I just draw a dotted line here. Then this angle I call it theta. So if you see this angle and this angle, so these two are corresponding angle. This angle is also theta. Now the slope is defined as slope m is defined as tan of the angle made by the line with the positive direction of x-axis. So slope of AB, MAB equal to tan theta. Now if you use the basic trigonometry, then tangent of tan theta is opposite upon hypotenuse, that is BM over AM. So BM over AM, and what is BM? BM is y2 minus y1. So y2 minus y1 over x2 minus x1. This also we use like slope of the 2 points when the coordinates x1 y1 and x2 y2 known. So the slope is always y2 minus y1 over x2 minus x1. So now again, just a little while I'll clean the screen. I'll discuss the idea of the section formula. So yes, so in the section formula, suppose there is a point P here between A and B with the coordinate x comma y, and this P cuts the line segment AB internally in the ratio m to n. So AP is m and PB is n. So now here I draw a line parallel to this line. So now this becomes 90, this is 90. Now this is A, P, I call it as N. So I have two triangle APN. APN, triangle APN and ABM and triangle ABM. So now you see this angle theta here is common to them. So this angle theta is common and this angle 90 degree, these two angles. So by AA test, triangle APN similar triangle ABM. So do you see this? So now these two triangles are similar because this triangle is similar to this tiny triangle is similar to this whole triangle, and we know that when the two, now let me remove this part because this is coming in between. Now you know that when the two triangles are similar, their corresponding sides are proportional. So I go for the smaller side, so I write AP over AB equals for the base, or you can see, you can take this one also, AP over AB, and then this is equal to AN over AM. Now I just use invertendo, as I reciprocal them. So what I get, AP I am writing as PA, sorry, since I am inverting I should have AB over AP is AM over AN. Now I will use the idea of invert, this is called dividendo, we're subtracting one from both sides. So I make this line little smaller, and then suppose I am subtracting one from both sides, so what I'll get, AB minus AP over AP is AM minus AN over AM. Now AB minus AP, this whole is AB, AB minus AP is PB, so this is PB upon AP. AM minus AN is MN, so this is MN upon AN. Now PB, just look at this, PB is what, N, so PB is N upon what is AP, M, is equal to, now I have to go for MN, so now this is my M and this is my N. So remember the coordinate terminology. If this coordinate have the point x, y, it means this part from here to here is x, and from here to here it is y. So from here PA, so this distance from P from here to here, this is x, like this, and from here to here this is y. So now see, this is y1 and this is y, so what is this part? This part is y minus y1, and what will be this part? This is x1 and this is whole is x, so this part AN will be x minus x1, x minus x1. So now we got MN. What is MN? MN is this distance. What is this distance? This distance is x2 and this distance is x, so this is x minus x2. So what I'll get, x minus x2 upon AN. AN I just found out, x minus x1. So x minus x1. So now I'll cross multiply, then what I'll get? So I get mx minus mx2 is nx minus nx1. So mx minus nx equal to mx minus mx2, mx minus mx2 and nx minus nx1. So I took this nx on this side and this is on this side, so I get mx2 minus nx1. So this is m minus n times x is mx2 minus nx1. So x will be mx2 minus nx1 upon m minus n. But this is wrong somewhere. Where? Because P is cutting internally. So now again I have to find what is mn. So this is m and this is n. So what it is? this is x2 minus x. So I have written here x minus x2, it should be x2 minus x, and this is an. So this is an and this is n. So this is, because this point is x minus x1. This is right. So just let me clear this. So now here you see that what I got mx2 minus mx is nx minus nx1. So I write mx2 plus nx1 is nx plus mx. So this is mx2 plus nx1 upon m plus n will be x. So it means the coordinate of the point P here is going to be mx2 plus nx1 upon m plus n. Similarly, if I go for the third side to find the y1 component, because here you see Pn upon Bn, Pn upon P, because for vertical means Pn upon this part Bm. If you carry on using this, then you can find the y, and that will come as mx2 plus nx1 upon m plus 1. These days derivations do not ask, no one asks in the examinations or in the competitive examination, but sometimes we feel like the student must know because they have studied the analytical geometry in class 10 and this is coordinate geometry, so they can understand why and how they have got this formula. So that's why I try to use this one. Now again I have to clear the screen so that I can come back to my more specific. So this is mx, this is called the internal section. Why this is called internal section? Because P lying inside the between the A and B. So if P lies between A and B, this is called internal section. But suppose if P is here outside this, so the ratio, and we say the ratio m is to n, it will be treated like this, m is to n, and in this section the formula will become just negative. So for this is internal section, and for external section this is mx2 minus nx1 upon m minus n, and my2 minus ny1 upon m minus n. So again we go for the midpoint. Midpoint means if P lies internally between them, so the ratio m is to n will become either m is to m, both same, or the n is to n. So this formula will become mx2 plus mx1. So this becomes midpoint. So this becomes mx2 plus mx1 over m plus m, my2 plus my1 over m plus n, and this literally becomes x2 plus x1 by 2, y2 plus y1 by 2. This is the coordinate of midpoint of the line segment whose extremities are a, x1 y1 and x2 y2. Thank you very much, and in the next video we will discuss again coming back to the straight line to find the straight line in terms of the coordinate.